So we have a soccer player running forward. That's important. At 7 meters per second. Okay, I'm going to stop right here. This right here tells me everything I need to know in order to find component form for the runner or for the player. So the player, the speed is the same as magnitude. So the magnitude, their magnitude is 7. Now let's talk about the direction. Now this is where we get a little icy. I want you to always go back to the coordinate plane. Go back to the unit circle. It goes back to that. This here, 0, 90, 180, 270. Okay, we don't worry about 360. We just say 0. Okay, so here, if I'm going forward, would you agree that that means I'm going this direction? What angle am I pointing to? 0. So the direction for the player is 0 degrees. So I'm going to pause right there. Let's find the vector for the player. I wrote it on the board. Also, delta x, magnitude cosine of the direction. Delta y, magnitude sine of the direction. So let's do that for the player. I'm going to take 7 cosine 0, 7 sine 0. Go ahead and figure out what you get. Cosine of 0 is 1. 7 times 1 is 0. Sine of 0 is 0. 7 times 0 is 0. So this is my vector for the player. This right here is my delta x and delta y for the player. We got that? Now let's move on to the second part of the sentence. And then we're going to, he or she kick the soccer ball. Now we got a ball, okay? The ball had a velocity of 30. That's the speed or the magnitude of the ball. And the angle was 10 degrees. So let's talk about that, the ball. The ball had a magnitude or speed of 30 and a direction of 10. Do the same thing for the ball. Okay, for the ball, you're going to take 30 cosine 10, 30 sine 10. Now, to be consistent, we're just going to do everything to the thousands place because that's what I did on my answer key. Go ahead and type that in so you can get your component for the soccer ball. Jeremiah, you okay over there? We doing something over here on number 4. So go ahead and type that in, see what you get. You got 30 cosine 10 and 30 sine 10 to the thousands place, 3 numbers. So I got, for the ball, thank you, I got 29.544 and 5.209. Anybody else get that? Okay. These two vectors together is the kick. The ball and the player together create a kick vector. This is delta x, this is delta y. So what I need for you to do is we're going to come up with a kick vector, which is the player plus the ball. So pick up your calculators, add together your delta x's, see what you get. Add together your delta y's and see what you get. Oh, everybody coming back from the field trip? You can just leave it cracked. Okay, go ahead and see what you get. Okay, this is what you should have. Now, this is the vector that we're going to use, the one I have in green. We're going to take those two vectors and figure out what the speed would be together. So I wrote on the board. You need to start memorizing those formulas. You'll have them for the skills check, but you won't have them for the test. So when you're asked to find the magnitude, you take the first number squared plus the second number squared, and you take the square root. So the actual speed for the kick is going to be the square root of 36.544 squared plus 5.209 squared. Type that in your calculators and see what you get. This is due Wednesday. If you have your homework 17 that's due today, you put it in the red. Oh, I did. And this one is due Wednesday. So what I got for the speed of the kick was approximately 36.913 meters per second. And no, I'm not concerned about unit, but that would be the unit for, because we're talking about meters per second. We use the same unit that they had individually. So when we started off, we were talking about meters per second for the ball and the player, so we end with meters per second. Who had that answer? All right, so let me go back a step. Let's look at our vector. Let's look here. Notice that x was positive and y is positive. What quadrant am I in? 1. What is your angle range for quadrant 1? So you need to pay attention to that. So we're getting ready to do our direction. We need to pay attention because if it's not, that means we're going to have to add 180 or 360. So let's see if we get a number between 0 and 90. So direction would be the inverse tangent, 5.209 over 36.544, and I got 8.112 degrees. Do I need to add anything? Is that between 0 and 90? Okay, I'm done. And that is my answer. That's what we're going to keep doing. These questions represent two vectors. Two things. We're going to add them together and then find the magnitude and the speed. All right, let's look at the next one. Question number 5. So we have Nadia. Nadia is rowing a boat across the river at an angle of 15 degrees east of north with a speed of 7. That was a lot. Let's talk about what they just said. First thing first, let's talk about this is north, this is east. Now, if it says 15 degrees east of north, that means I'm starting here and I'm rotating this direction. So that angle that they just gave me was this angle. That's not the direction though. So the whatever direction comes after the word of, that's where I started. So because it said of north, that means I started here and I'm going this direction. If it said north of east, then I would have started here and went this direction. All right. But don't worry, we didn't even make it that complicated on the test. This is just general knowledge for you. Okay. But I don't need that angle. Whenever we talk about direction, it is always this angle. How do you think I'm going to find that angle? You can leave it cracked, 'cause I think more people might be coming back from the field trip. Okay. How do I find that angle? Subtract it from 90 degrees. So here's a couple formulas that I'm going to rewrite. You should already have it, but in case you didn't get it yesterday, let me write it again. Heading is 90 minus the direction. Okay? Which also means that direction, that's 90 minus the heading. Because together they're complementary. You have to pay attention to that on the test. So this here, this is what I'm going to use for Nadia. So let's talk about Nadia's vector. Nadia, her speed is 7, so that's her magnitude. Her direction, theta, is 75. So when we make her vector, it's 7 cosine 75 and 7 sine 75. Go ahead and find that. Lariah, if you have your homework 17, I collected it already. Put it in the red tray on my desk.
I had it.
Oh, you put it in there? Okay. So again, we'll just do thousands place, make it simple. Hey, you can leave it cracked just in case more people are coming back from the field trip. So that would be my Nadia. That's Nadia. Nadia would be 1.812 and 6.761. We all got that for her? All right, this is her delta X and delta Y. But she's rowing her boat against current. So let's talk about the current. The current has a speed of 3 or a magnitude of 3. And, and it says it's going west, due west. Now, go back to, you'll never eat soggy waffles. Let me go ahead and draw this real quick. North, east, south, west. Going back to our unit circle. We remember, we started at 0, and over here we were 180. You need to know that if the wind or current is going west, you're using 180 for the angle. If it's going east, you use 0. Now this one said that it was coming from the east. if I'm coming from the east, that means I'm not going east. What direction am I going? West. What angle do I use for west? 180. So now you need to find your vector for the current. You're going to take 3 cosine 180 and 3 sine 180. Go ahead and find that. You should have negative 3, 0. Who had that? So now I have 2 vectors. What do you think I'm going to do with these 2 vectors? We're going to, well, before we find the magnitude, we got to add them together. Okay, I need to take Nadia's vector and add it to the current. So I'm going to add both of my delta x's and my delta y's. And I'm going to create a new vector that has both forces. All right, that's what I got. Who had that? All right, I want you to, before we continue, magnitude is simple. It's the direction. That's what I'm thinking. If I had to guess, because the test next week should not be hard. What are we going to miss? It's the direction, because you have to think about the quadrant. Show me with your fingers, what quadrant is this vector in? It's in quadrant 2. What is your angle range in quadrant 2? Keep that in mind when you do it. That your answer should be between 90 and 180. If it's not, I'm taking off points. Okay? So use this vector. I want you to find the speed or magnitude. So magnitude or speed, same thing. You always have to put a negative in parentheses when you are squaring it. Hopefully you all know that. If not, if you don't, you won't get the right answer. That's how you find your magnitude right here. And your direction is always tangent. Inverse tangent of y over x. So I'm going to give you a couple minutes to find both of those numbers. And again, if you don't get a number between 90 and 180, you got to figure out what you need to add to it. Just a reminder, you can start bringing in your pre-calc books. No more homework out of the book. Start bringing them in. Get them checked in. They $200 and some. So, turn them on in now. So the speed that I got for the Nadia and current was 6.865 miles per hour. So the speed magnitude, 6.865 miles per hour. Anybody else get that? All right, the direction, when I typed it in my calculator, it gave me negative 80.034. Is that in between 90 and 180? What did you add to it? All right. So the final answer would be 99.966. Yes. So you need to keep in mind that your answer needs to fall between 90 and 180. You're either going to add 180 or 360. Yeah. Which one's going to get you there? All right, last one that we're going to do together. The last one you on your own. I'm going to check answers. Okay. We got a plane. A plane flying in the air at a speed of 525 degrees. So we got a plane. And this plane has a magnitude or speed of 525. It gave me the heading. Do I use the heading? No. I need the direction. How do I find the direction? 90 minus 47. You have to use 43. So, go ahead and find your vector for the plane. 525 cosine 43. 525 sine 23. And for those people who came in a little late because you were on the field trip, this will be posted. The recording will be posted. I recommend you go back and fill in anything that you may have missed. You have a skills check tomorrow. It is open note. So you need to have complete notes. So go ahead, type that in, see what you get. Oh, we're homework 17. Why? Why not? It's the last couple. So that's the vector you should have for the plane. That's the airplane. That's my delta X and delta Y for the plane. All right, then it says that we have wind. So let's talk about the wind. The wind is blowing from the east. If I'm coming from the east, what direction am I going? What angle? 180 for west. So the speed of the wind is 18. So the magnitude is 18. The direction of the wind is 180. So what I need for you to do now is write a vector for the wind. So the wind, that's 18 cosine 180, 18 sine 180. See what you get for the wind. should have negative 18 and 0. So now we need to create a vector for the plane plus the wind. So plane plus the wind vector. I'm adding together my change in x, or my horizontal, and my vertical. So the wind, since we're going against the wind, the speed is slowing down. Okay, so 365.961, 358. Now both of these are positive. So our direction needs to fall between 0 and 90. So I want you to use this vector right here. Use the formula for speed, magnitude, and for direction, and find what you get. Oops, I didn't mean that. Okay, this is what I got. I got 511.983 for the speed, and I got 44.374 for the direction. But there's a reason why I didn't circle that. Let's go back to the question. What did it ask us to find? The speed and the heading. So, how do I find the heading? Yes, 90 minus 44. You got to pay attention. Make sure you're answering the question. So what I'm really looking for is 45.626 degrees. All right, the last one, you're on your own. I'm going to get you started, and then I'll show you the answers at the very end of class. 7 is just like 6. So we have an airplane. The plane, does it say heading? It says it's creating a 42 degree with the ground. So that's my direction. So for the plane, 42 is my angle and my speed is 405. So you got 405 cosine 42, 405 sine 42. Now let's talk about the wind. It says the wind blows 25 miles per hour from the east. From the east. Is that 0 degrees or 90 degrees? I mean, not 90. It's never 90. Is it 0 degrees or 180 degrees? 180. So you got 25 cosine 180. 25 sine 180. They want you to find the speed of the plane and the wind, and it also asks for the heading. When you get your answers, raise your hand and I will check it. If you're watching this online, pause the recording because I'm getting ready to show the answer.